Hello and welcome everybody. It's an incredible honor to be the last talk of the day and to end this beautiful conference. But I want to feel the energy. Are you still energized? Yeah. Come on. Great to see also some familiar faces. That means that I have won the battle of the conference halls. And yes. Welcome to Event-Driven Architecture Patterns for Streaming Data with Apache Kafka. So, to kick it off, I want to ask you a question. Who of you already uses Kafka or operates Kafka in production? Who has the experience of running Kafka in production? I see a lot of hands, and that's good, because otherwise I would have been screwed with my talk. But all those people that raise their hands, they know the struggle, right? Operating Kafka is a huge and complex task. There are a lot of things that you really need to do. And don't get me wrong, I love Kafka. You can have really great use cases with Kafka, but it is complex. On the other hand, on the other end of the spectrum, we have event-driven architecture. In its essence, event-driven architecture is all about making things simpler, removing the complexities, and making simple systems. So in case you are still wondering who is talking to you, my name is Patrick. I'm a solutions architect at AWS since 2022. My background is I was a consultant and a developer for other complex systems like microservices, and I had fun with Kubernetes. Another complexity in my life, which I consider my Kafka and my event-driven systems, are my two children. Complex and also not so much complexity. I'm also a big fan of sci-fi films and sci-fi movies, which I guess is the reason why I'm in the IT industry. And for all those who also suffer from imposter syndrome, I'm one of you. I'm what I consider myself a professional imposter. So I like to go one step back. In fact, a couple of years back. When we talk about event-driven architecture and what actually event-driven architecture is, we usually talk about complex systems, complex distributed IT systems. But the thing is, complexity isn't exclusively for IT systems. Complexity was also relevant back in those times, roughly 100 years ago, where the picture depicts a plant from the Ford Motor Company. And what they were building was essentially an airplane or a car. I don't remember, but it doesn't matter, because building a car or a plane is a complex task. You have tires, you have engines, you have the metal plate, you have the chassis, you have the glass, electricity, and all of those funny things. So what we see in the picture is a revolution for its time. They took away the complexity by introducing the mass production. We see, in this case, a domain boundary, women that are basically doing one thing and one thing only, taking messages or stuff from the production line for the conveyor line, building something with it, putting it back, and sending it to another team that essentially does something with it until the product is finished, right? So you might ask yourself, still, what actually is event-driven architecture in the case of complex IT systems? And why is it even important? Why we need to deal with it? Because we have all been this aspiring architect, right? We have all worked with microservices or with complex systems, and we know that the solution we begin with is putting a REST API in front of it, and that's basically it, right? All the time. As I come from a company that is famous for e-commerce, I want to take an e-commerce example. So what we have here is a user that buys something. Pretty simple. And the e-commerce backend consists of 4 microservices. We have one central ordering service that orchestrates the order. So it calls the ordering fulfillment service. It then, after it has been successful, updates the order status in the payment system, right? And then the last part is to add loyalty points to the customer in the loyalty system. And that's simple. It works, nice and dandy. But the reality is, and we all know that, technology fails all the time. So what happens in this case when the payment system is down? We have a 500 error. Like, we know this. This happens all the time. Even in our browser, when we call something, 500 error, boom. Well, you could say that, okay, we have an error that's pretty simple. We can revert the order fulfillment. We can have some logic in the ordering system that takes care of that, and reverting the order, and that's done. But when you think about it, there are certain things that are not as simple because it involves many business processes. So let's say I'm the customer and the PlayStation 5 was released, and I was one of the lucky few that really was able to come through with the online to the online store and actually click buy. I would be really pissed if along the line the order would be if it threw an error. So what do? We revert this technically and we send the customer the notification, sorry, couldn't process your order because our payment system was done. That wouldn't be the best customer experience, right? What about another case? What about the payment goes smoothly, but the loyalty system times out? Well, you could say we can still revert the order and revert the whole process, but is the loyalty system a necessity for the process? Do we really need it? So the thing is, what I'm trying to tell is there are certain problems that are not only technical, but also cross domain boundaries and involve business processes that we need to rethink and reshape in order to have a cohesive, good customer experience. And this problem with synchronous invocation of backend APIs even introduces another problem when we want to add another service. So in this case, we added the CRM system, the customer relationship management system. So what we end up here in this architecture is tightly coupled system. And tight coupling is bad because it introduces dependencies between systems. We cannot exchange it anymore, and we're stuck in an endless loop of errors and doom. So, okay, we understand distributed systems are challenging. They're not as simple as that. What do we do now, and how can event-driven architecture help us here? So I brought this textbook definition of what event-driven architecture is. And it's an architectural style of loosely coupled systems that communicates through emitting and consuming messages. I want to highlight the key parts here. It's an architectural style, agnostic of technology, agnostic of containers, serverless, virtual machines, whatever. And it's a system of loosely coupled systems, so loosely coupled, no dependencies between each other, and communicating through events or messages. So I'm an architect, and as an architect, I want to draw diagrams and boxes and shapes. So let's do this, right? Let's draw a diagram of what event-driven architecture looks like as components. So on one hand, we have a producer that produces events. This can be an application, this can be code, this can be database, this can be an S3 bucket if you're familiar with that. And it reacts to changes of like an image upload or changes in the database, or something was triggered by a business process. On the other side, we need to have a consumer that reacts to those events. It consumes them, it can be the end of the process, or it can emit other events. And what the component that we also need in this architecture is the event broker. So we need to have something that builds the bridge between the producer and the consumer. And for those people that raise their hands, and one of them is on their mobile phone, that know Kafka, this looks familiar, right? So yes, this looks absolutely familiar. And you have seen this before, because it is, at the end of the day, looking like Apache Kafka. So For those who didn't raise their hands and don't know how Apache Kafka looks like, the architecture on a high level, and don't worry, I'm not going to get into the nitty-gritty details of how a Kafka works on the under the hood. It looks like this. We have producers that produce messages or that commit messages to a topic in the Kafka cluster, which consists of several servers which act as broker nodes of nodes that where the topics reside, where the messages are sent to. And on the other hand, we have consumers that read from those topics the messages and do something with it. And now you could ask yourselves, okay, so we have the producer, we have the consumer, we have a broker, so we have event-driven architecture, right? Wrong. Kind of. Since we're only 10 minutes inside this talk, the spoiler, this is not necessarily event-driven architecture. So what is it then? Yeah, well, is it a service bus? Kind of. It has these things where we send things to it or events to it. Yes. Is it like a synchronous REST API? It has an API. It is asynchronous. Could be. Is it a database? Well, it persists data, but trust me, never use Kafka as a database. I've seen that. Not a good idea. You can do that, but it's not a good pattern. And Kafka is kind of like everything of it, but none of it. So what is the textbook definition of Kafka? And by now you should know that I love textbook definitions. I brought 2 of them today. Apache Kafka is a popular open source software built for real-time streaming of data. And the key points that I want to bring here and I want to highlight here is Apache Kafka, of course, and real-time streaming. Kafka can do a lot of things. It can be the backbone of your event-driven architecture, but the real benefit and the real power comes from real-time streaming of data. So this concludes that event-driven architecture, as I already said, it's not about a specific technology. It can be any technology you can think of. And of course, even though this is per se not an event-driven architecture, it can be part of an event-driven architecture. And today, we're going to see some patterns how Kafka can be involved in an event-driven architecture. But first, congratulations. You have all been promoted to lead architect in the new company that does something. And full disclaimer, this is a use case I have worked on with a customer. So this is not something that I have invented, this is a real use case. So you have been an architect that have been involved in a new company or in a company that operates an on-premise Apache Kafka cluster, and they want to move to AWS. And the Kafka cluster will need to talk to various consumers. We will start with 3, but up to 50 plus consumers. The problem is, though, the producers send the messages through Avro to the Kafka cluster, but the consumers, they need to talk JSON. And for those of you who don't know what Avro is, basically it's an efficient binary format for having efficient messages inside Kafka topics. The other non-functional requirements, or architectural characteristics, as I like to call them because it sounds nicer, is we need to have order. We need to persist the order of events, and we need to have single-digit second latency. That means up to 9 seconds is okay. After that, it won't work. So what could we do? Well, we could use this in a Kafka cluster and don't bother with some fancy integration patterns, right? We could have a cluster, a Kafka topic for the Avro messages. We could have a consumer that pulls the messages, enriches them, or transforms them into JSON objects, and puts it into a dedicated topic for JSON objects. And then we could spread it to various different consumers directly, or we can use a Kafka sync cluster that basically pushes all those messages to their destinations. This can work, and this is not a bad idea, and definitely not a bad approach. But there are certain drawbacks. For one, the consumers need to be aware of Kafka. So we need to have consumers that are aware of the Kafka cluster in the case of, in the upper case, where we have multiple consumers reading directly from the JSON topic. In the other case, where we want to have a Kafka sync connect cluster, we need to operate this. So there's the burden of operation, the burden that we need to invest of doing this. So what other patterns can we do? Well, we said that we want to go to AWS. And what can AWS do in terms of event-driven architecture? And by the way, this is not an extensive list of all the patterns and all the possibilities, but for the use case, these are the considerations that I had. So who of you is aware of all these services? Just hands up or down. Okay. So to explain this, Amazon SQS is a service, simple queuing service for a message. It's basically a queue for point-to-point integration between a source and a target. It works by the producer pushes something to the queue, or some producers push something to the queue, and we have one consumer that pulls the message out of the queue. So it's a pull mechanism. On the other hand, we have Amazon SNS, simple notification service. Now, it is for one-to-n public publish and subscribe mechanism, where we have one publisher that pushes messages to the SNS topic, and we have multiple subscribers that can actively receive the messages by a push mechanism. So it's a push mechanism. The third option is Amazon EventBridge, which we also call the backbone of event-driven architectures. It works by a similar fashion like SNS. It can push the messages to destinations, but there are two specific things about EventBridge that I want to highlight. So for one, EventBridge offers an event bus where all those messages can be filtered and routed to the destinations. On the other hand, EventBridge offers a service that's called EventBridge Pipes, which is point-to-point integration, a managed service for point-to-point integration with the various sources that you can connect to, and it easily delivers the messages to the destination. The cool thing about Pipes is that that's basically, by the way, it's a managed service where you can have filter mechanism and enrichment step in one service, in one flow. So how would this look like? And this was my first iteration. So we had the Kafka cluster on the left-hand side, where all these messages came from, where all these topics were, and I integrated this with Amazon EventBridge Pipes. The next step was to integrate this with Amazon EventBridge as an EventBridge bus to distribute it to all the consumers. I set the rule where the messages were then evaluated and sent to consumers. Now this looks like a really clean decoupled architecture, right? There are certain points that are not that good. So for instance, as I said, the messages enter as Avro messages. So it's impossible to filter them because it's binary. You cannot filter binary data. You would need to have a Lambda that transforms it, and then you could filter it. So we could then filter them or transform them in the enrichment step, and EventBridge Bus would then have a rule that evaluates this and send only the relevant messages to the consumers. So that would work. So what about the non-functional requirements or the architectural characteristics? Single-digit second latency, and we have to persist order. Well, EventBridge Pipes guarantees order, but EventBridge Bus doesn't. So that's not an option. So you could say, okay, since EventBridge Bus doesn't guarantee the order, we can use another destination and have the order. But unfortunately, as of right now, EventBridge Pipes doesn't allow the destinations of FIFO, so first in, first out queues, or first in, first out SNS topics, which would guarantee order. So what can we do then? We could use the lambdas. Lambda Event Source Mapping. Under the hood of Amazon EventBridge Pipes, the mechanism that pulls messages from a source and sends them to the destination is exactly the same as in event source mapping. And if you are aware of Amazon Lambda, it's a serverless compute service where you can define Lambda functions that do one thing and one thing only. But when you use event source mapping, there's another mechanism. Amazon AWS Lambda is a managed service, and when you set up event source mapping, it manages the integration of your source to the destination without touching any code. The code comes for the target here, in this case, where the Lambda function. So you could specify how to filter something, how to filter on the destination, which still doesn't make sense as it's Avro. And you can define the batch size of your destination, so how many events you want to process through AWS Lambda. So how could a loosely coupled event-driven architecture look like in this case? So of course, we start with our Apache Kafka cluster, and then we integrate it with AWS Lambda and use event source mapping to get all those messages from the Kafka cluster. In the code, we define the filtering or the enrichment, so the transformation of Avro to JSON, and the custom code allows us to write code or send code to absolutely any destination we want. So in this case, what we need and what helps us is SNS, FIFO. The next step, and this is a trick that helps us to decouple the architecture even more, is we don't send it directly to consumers. We send it to SQS queues. Give me a second and I will tell you why. And from there on, we give it to consumers. So, why the SQS queues? First, it allows us to further decouple our infrastructure, our architecture, and give our consumers more space and more time to process the events. Remember, SNS is a push-based mechanism that gets the messages and pushes it to consumers. So what happens when a consumer goes down? And technology fails all the time. If a consumer goes down and the message is pushed, the message is lost. With Amazon SQS, we have the ability, or with the queue, we have the ability to have some sort of persistence, some sort of buffer. And we also give our consumer the ability to process these messages at its own pace. Another benefit is the modularity we have from that, because we now have the flexibility to exchange the consumer through another service if we want to. We can use the Kubernetes cluster for one of consumers, or we can switch it to AWS Lambda for whatever reason. Decoupling gives us the flexibility to modularize our workloads, to modularize our architecture, and give us freedom and agility. So, yes, we have to write our own code. We have to maintain this. It's not as managed as in EventBridge Pipes. But we also have a flexibility, and the flexibility to do and send the message where we want to. The other thing is, by introducing SQS, we offload downstream customers from the push-based mechanism. Now, how would the code look like in the Lambda? I said we have to maintain it, so it sounds complex, but there are actually two things that is happening. We have a block. The first block, we see that we have the enrichment step, which is taking the Avro bytes, decodes it, transforms it into JSON, and that's it. And the other thing is we have to maintain a client that basically sends the string, the JSON string, to the destination. Now that we introduced some services here and there, you could ask yourself, okay, what about my bill? What about the costs that are generated? And yes, we introduced new services, so there are costs attached to it. For roughly 1 million events we're talking about 20 cents for the Lambda function. And by the way, this was my experiment. This is not representative of a real use case, so it will vary based on what you actually do and how you and in which region you deploy it. But in my case, it was 20 cents. For SNS topic, it was roughly $6. And for the SQS queues, it was 50 cents each. Yes, we generate costs here, but what I'm trying to tell you, or what's important, what the main takeaway is, if you look at the costs from the situation of an event-driven architecture, of a loosely coupled architecture, and compare it to legacy architecture, roughly 100 million to 1 billion events equate to 1 engineering hour that needs to operate the Kafka Connect cluster or the legacy software. So you always have to look at the big picture of how architectural decisions impact your costs and how also the processes that you had prior compare. The other architectural characteristic that we have is the persistence of orders. So how would that look like? Excuse me, the latency. With my experiment, again, it's my experiment, so it's not representative for all Lambda functions everywhere. It's 50 milliseconds for the Lambda function, for the event source mapping. It's roughly 61 milliseconds for the SNS, and also kind of 61 milliseconds for the SQS queues, which is still way below our, like it equates to 180 milliseconds, which is still below our requirement. So the bottom line is here, yes, there were some iterations that we had, and none of the solutions is perfect. It is always, as architects, we're communicating with trade-offs. We're dealing with trade-offs. We really have to look at the big picture and see what trade-offs we're exchanging, what options we have. So, okay, we passed the first test as a new architect. We were successful. We could provide an architecture that worked for the customer. What next? Well, the customer wants to have some real-time analytics, and the customer wants to have persistence of the messages in the Kafka cluster. Cheap, of course. It's always cheap, right? And what we begin again is with the Kafka cluster. So that's the beginning. And for the real-time streaming, are you familiar with Elasticsearch, open search service? So it's very suitable for real-life data analytics streaming or observability. And Amazon OpenSearch is nothing else than Elasticsearch. OpenSearch offers the option and the service to use OpenSearch ingestion, so a managed way of integrating a source to the destination and integrate it easily to OpenSearch. So nice, real-time streaming done, check mark. What about archival? So we could use here AWS Glue. AWS Glue is a managed service for ETL workloads, so extract, transform, and load. There we define the pipeline, so we define the source, the Apache Kafka cluster, we define the enrichment in the Glue service, and we define the destination, which is S3, a simple storage service which offers archival and tiering of storage classes. So we can tier it directly to the Glacier storage layer, which gives us the flexibility and the ability to store the messages in a very cost-efficient way. Now, the beauty of it is we can delight our business owners, because business owners love metrics, they love business intelligence dashboards. We can do this easily. With Amazon Athena, we can have real-time SQL queries based on JSON or CSV or Parquet data in our S3 bucket. And Amazon Athena gives us a JDBC connector, which lets you connect a business intelligence tool of your choice to Athena. In this case, I chose Amazon QuickSight, but you can easily opt for Power BI or for Tableau. So not only did we archive the data in a cost-efficient way, we also delighted our business owners with some BI dashboards. Okay, so what is the main takeaway? What are the main takeaways here? For using serverless event-driven architecture, the first thing is, by leveraging the platform capabilities, we can offload the operational burden, the undifferentiated heavy lifting to us, to AWS. You don't have to manage code anymore. you basically configure your managed service and automate your infrastructure. As I said, as of right now, EventBridge Pipes doesn't allow the integration of FIFO queues or FIFO SNS topics, but the platform evolves. Last year, we have 3,000 new features, new services that evolved based on customer requirements and needs. So the platform can evolve even further, which gives you the flexibility or the possibility of using managed service down the road. Another thing is we separated the concerns. We had separation of concerns. Through the architecture or through choosing event-driven architecture, we could separate business domains. So we had our consumers that were separated by SNS and SQS, that were managed by their own teams, which didn't cross team boundaries. We had our business intelligence unit separated, and we even had the real-time analytics observability team separated by using event-driven architecture. Now, we also had influence on the runtime characteristics because, yes, we didn't have to opt for a Kafka Connect cluster. We get rid of runtime characteristics because it doesn't exist anymore. By integrating even more managed services or serverless services, we get rid of the operational burden of maintaining code or maintaining an application or maintaining legacy. So this improves the runtime characteristics. And last but not least, we can reduce cost and complexity. And costs have two dimensions here. One, the financial aspect of getting rid of a legacy system that has to be maintained. But the other thing is opportunity costs, the cost of a lost opportunity. So instead of working on something productive, which has a business impact, opportunity cost means that you have a team that is dedicated to maintain and manage legacy software or manage a cluster that you could easily exchange for managed services. So before we finish, and I'm almost done here, before we finish, I have a very last word of advice here that I want to give you as a takeaway. First thing is, requirements, as we saw, are not always set in stone. Customers come with the wildest requirements and non-functional requirements. And the reason is not that they are bad or they want us to tease us or they want to punish us. Customers need education. We're architects. Our job, or developers, is to educate customers on best practices and why certain decisions don't make sense. In the case of the customer that came with the persisting order and sub-second latency, it was an intense discussion, but I was able to argue that the persistence of order is not that important for overall achieving the business goals. And again, it is our responsibility to outweigh the options and have and showcase the impact of why certain requirements have on costs and complexity. The other thing is we zoomed in on two use cases here, on two small parts of the architecture. But we need to take a step back and look at the bigger picture. Our decisions as architects have an impact on other teams. They have impact on the technology stack, on the customer, on the consumers. So we really need to take a look at all the decisions that we make and how they might influence other parts of the architecture. For instance, costs. Yes, costs may rise. But on the other hand, the decisions that we make may lower costs somewhere else. And the last thing, see what the platform can do for you and keep at it. The platform evolves, AWS evolves. We release new services, release new updates. It is crucial in our industry to be on the pulse of what's happening and seeing the news. Of course, it's not possible to grasp anything and to be everywhere. But in your area of expertise, it's crucial to know what's going on. If you want to learn more about event-driven architecture, I invite you to take out your phones now and scan this QR code, and you will be redirected to a nice webpage where there are certain diagrams and graphics and workshops of how event-driven architecture works. Now, as a disclaimer, there are way more patterns that I described today, but we A, only have 45 minutes, and B, it would be pretty boring talk if I would go through all the patterns. And the last thing before I finish off and leave you to the awesome party today is reach out to me if you have any questions. So you can take a picture. You can still take a picture of my name and my LinkedIn. You can connect to me. And if we don't have the time for me to answer all your questions, you can bombard me with questions and requests. I'm happy to help and to answer all of them. And with that being said, thank you very much for being here, enjoying my talk. I hope you enjoyed it, for listening, and I'm really super curious about all your interesting questions, and I really have to think who I'm going to pick.
Well done. All right, I see already a raise of hands. I'm going to go here first.
Patrick, thank you so much. It was a really interesting talk. So my question is about testing and debugging all this pipeline, because configuration, as far as I learned, is really hard to test. We cannot apply unit tests. We need to spin up some testing environment for that, the whole pipeline. And how can we debug some tricky situations like when this pipeline loses every 10th message, or maybe some messages reach one destination but don't reach others. So could you please tell the best practices for this? Thank you.
This is a super good and very relevant question, and I wish I could say that there's this definitive way of answering this. There are options, and you have to see how it works for you. So one option and one good practice is these services are cheap. You saw that for 1 million events, we have roughly $6. So one option could be replicate the same architecture in a test environment and just test it kind of live. This could be one option. Another option is there are unit test frameworks that mock the services. But the problem with it is, do they really mock those? Do they really have the same look and feel and the same? They behave the same way as in live? Not necessarily, but maybe for a part of your architecture, this can be what can help you to solve the issue. And the other is if you use code and like the Lambda way, I think there's a beautiful way in the serverless framework to deploy your function as a Docker container or as a container environment and use it like that. And yeah, those are the three big ways of how you would test it. But again, there's no best practice. So it's an area where we need more improvement and more open source software.
Gotcha. Great. Can I go here?
Yeah, hi. Thank you. Thank you for your presentation. That was really interesting. And actually, I have like two questions. The first one is, as I remember, you suggest to use Lambda because of we're using an Evro scheme for Kafka, which represents our data in binary format. So we cannot filter our data from Kafka and send to the particular, let's say, consumer. But correct me if I'm wrong, but Kafka supports the thing that called partitions, and on the producer side, we can send our packets of data even in binary format, probably to the particular consumer by those partitions to the particular partition group with some of the consumers. So maybe this is the way how we can rid of this lambda part of the whole architecture.
Yeah, so in this case, in the real use case, the issue was that we didn't have the control about what the producers are sending. We had to deal with what was there. And the other thing is, if I understand your question correctly, is that we have partitions that are used as JSON, right?
Yep. Yep.
Yeah, this was in this use case. If you have influence on the team that does this, absolutely go for it. But in this case, we didn't have this, so we needed to have some sort of a computational step that would need to transform the error to JSON.
Okay, yeah, thanks. And the second one is about, I don't know much about those fancy AWS services, but you mentioned that the last part of your architecture with Amazon SQS. Does this service has something like proof of delivery the event to the consumer? Because, for example, Kafka, when the consumer fetches the event from the Kafka, it sends like the response that the message is received, the fetched.
Okay.
And after that, the consumer can fail with the process of this event.
Yep.
So, does the SQS handles this?
So, first of all, I want to say that SQS was one option. You can use different queues and different technologies. It is absolutely technology agnostic. But what SQS offers is it's a pull-based mechanism. So the Lambda or the consumer pulls the message, and it has to send an acknowledge or a delete flag where after successful processing of the message or of the event or the message, it sends the acknowledge and the message is then deleted from the queue.
So the consumer sends the acknowledge. Okay.
Yeah.
Okay. Thanks. So
Sure.
Thank you.
Maybe one point to this question, and you can already move to the next one. The thing is, yes, things can fail, and you have to think of a path of how to mitigate issues if the consumer sends an ACK, but it didn't really process. So it's always a good practice to have a dead letter queue that for queues or messages that haven't been processed properly sends these to a dead letter queue that can be then looked on as by manual, by operations team, or by support team. So this is a best practice for SNS and for SQS.
Hey, my name is Roni. I also have two questions. The first one is, you mentioned in the beginning that you don't recommend using Kafka as a database. And I saw this become a trend a couple of years ago. I think I heard Alexei mention in the first talk that Gurtam is moving towards using MQTT as their new database. So I'm curious, the MQTT broker somehow as their new database. So I'm curious how, in what ways you're saying that you don't recommend Kafka.
Well, for one, databases have some certain characteristics that a Kafka cluster doesn't necessarily have, or topics. For instance, replication of data. Yes, Kafka has also replication. Yes, you can argue that. But what about snapshots? What about backup solutions? What about the SQL? Or like, you cannot do SQL on Kafka, right? And for other document-oriented database or NoSQL databases, there are performant engines that do the database job much more efficient than a Kafka cluster. So yes, you can use this as a database, but only if you can live with the fact that something won't, that some features from a real database won't give you the results that you have. Another aspect of why you shouldn't do this is to keep the data separated. So what you do in the Kafka cluster, yes, you can have multiple topics, but it would be still this Kafka cluster where your data resides. Whereas you want to have the data close to the domain boundary where it resides, to have efficient path of fetching the data within their teams, within team boundaries. So you not only have to look at the features, but of how communication patterns in your business domain happen. And if you have all in your Kafka cluster, it's breaking the contract and it's not according to best practices of communication flows. But it's a very good question.
Thank you. The second question was in the beginning you referred to benefits of moving from a synchronous distributed system to an asynchronous one. I understand for things like a loyalty service being down where we can move the events to a dead letter queue to be processed or retried later. But what about the example where the payment system is down and returns a 500? In that scenario, we can't really proceed with the payment, and I think we just have to interrupt the entire flow. Are there any benefits of moving to an async system for those types of scenarios? What can an async distributed system help with here?
Yes. So in the case where we would have the synchronous, call, and where the whole order would be then down because of payment system, is the order would be gone. Now this can be okay, and this can be okay, and this cannot be easily revertible. But if you switch this to an asynchronous pattern, where you basically would buffer the order through a queue or through a buffer event router, you could fulfill the order and live with the fact that the payment system is currently down. You could tell the customer, yes, process payment was down, but handle the payment process later when the payment service is up, because the message is still there. So that would be a benefit of decoupling this.
All right. One more question over here.
So the pattern is 2 questions. I'm going to proceed with that. First question, starting...
As long as they're event-driven.
Absolutely.
Very good.
We can talk about event sourcing later. The first question is pattern-based. So when we consume a message from a topic, right, I've seen 2 free ways, but 2 main ways to do it. One is you have a consumer job, job invoked by taking the message and then passing it to an API that actually does the saving. Because, well, in a microservice perspective, the microservice is responsible for that. The other one is the microservice running the consumer itself, so running both the API and the message consumer. Which approach does seem for you at least most beneficial?
You have to rephrase the question, because I thought we were referring to, like, again?
So, 2 patterns, right? You have a consumer service that pushes then the message to an API that takes in the data, processes it, or you have the consumer running on the API microservice. So directly integrated.
Got it. It depends. And now you might ask, depends on what? The thing is, if you follow the domain-driven design best practices, you have to look of what's happening in the business process, of how is the communication flow, what are the team boundaries. So what does the consumer do? If it's just basically routing the messages to an API, go the hell with it. Use basically an event router or bus that directly puts this to the API. Why not? The other thing is, again, look at the communication patterns. If there are more business boundaries across that are happening in the consumer or in the API, then really think what the benefit is to decouple it and to merge it. So there's no really clear-cut answer that I would say, yes, this is the best approach or this is the best approach. You really have to look at the context and what's happening there message-wise and how communication is there. Because you want to have efficient communication between services to reduce moving parts, to reduce the problems of introducing a moving part that could potentially break.
Okay, so then going towards the second question, from the architectural perspective where we had the SNS to SQS,
Yep.
That's correct? The question is, because now we're taking an event from an existing Kafka cluster, which is Avro, right? But in the new systems, moving on from legacy, we might still be producing to the same topics and we want to use JSON. So if SNS is one-to-one, how would you go about...
SQS is one-to-one.
Yeah, the latter part that goes to consumer, right? Because it takes from SNS a direct push to a consumer, but as far as it knows, it is only taking from one source. if I'm correct.
Yes, but why we introduced SQS in front of the consumers is not that we want to have one direct one-to-one communication. So yes, you can obviously get rid of it if it makes sense. But the reason why I added it in the architecture was to give the consumer actually the ability to offload the traffic and pressure on the downstream services to produce and process the events on its own pace. The other thing is you can have for one SNS topic multiple SQS subscribers independently. So you don't really need to have one SQS, but multiple ones in parallel.
Right, but if we are deciding to push to the same topic but JSON, right, like suggested with partitions, then would we still be able to apply the same architectural pattern?
If we, on the Kafka side, would
Yes.
have on the same topic JSON?
Yes, from the new system, and legacy is still pushing Avro. So how would we handle that?
Where would the new system reside? Still in
AWS, let's say. That's
yeah,
fine.
no. I mean, on the left-hand side, where we would have the legacy system that is exchanged to the new system.
Yes, it's a publisher of the topic.
Okay. Yes, it would work. The benefit which we have here is we could then use the filtering mechanism in AWS Lambda because it's now JSON. But the architecture would still be relevant and would still work there because nothing inherently changes there. What we need to change is, of course, the code that does the enrichment sim, so the transformation of binary to JSON. But for SNS and SQS guys, this would still work.
Okay, thank you.